What up? Today we're going to do a paper because you guys seem to find these very useful when I do them, and that's what this channel is about, is giving you some academic self-confidence and helping you through your exam periods. So I'm going to go through this exam today. It's a Pure 1 exam, 2019, May, June, and we'll just run through this. Nice and easy, so follow along with me. And I noticed that like 70% of you guys that watch my videos aren't subscribed, so if you are watching this and you're not subscribed, can you please subscribe? You know, it makes me feel better, and you know, it allows more people to see this content. We can help more people do well in their exams. So okay, let's do question 1 here. So we've got find the term independent of x in this expansion. So this is a binomial expansion where k is a constant. So the term independent of x here is 540. So this is find the value of k. So let's find in the expansion the term independent of x, which will be, if we look at our formula sheet, and we look at this formula here, and we just think about it, well, the term where we're going to be independent of x is when this part, a in that part, in the expansion, the binomial expansion, because then we're going to get x cubed on this term, and also we're going to get an x cubed on this term. So that means that these x cubes will cancel. So if we work this out, we grab our calculator, times, this gives us 160, so this gives us 160k cubed, and then obviously these x's are going to cancel because you're going to get an x cubed on the top and an x cubed on the bottom. It's going to cancel. So this is our term in the expansion of this that is independent of x, and it says that that is actually equal to 540. So now we can find out what our k is. We'll get a k cubed equals 540 divided by 160, and then we cube root that. We get 1.5. So our k is 1.5. Cool. And then it says, for this value of k, find the coefficient of x squared. Well, let's just put this into here. So we have 2x plus k, which is 1.5, over x to the power of 6. And it wants us to find now the coefficient of x squared. Well, again, we have to think, well, how are these two going to times together where we're going to get a coefficient of x squared? Well, it's when we're going to have an x4 on the top divided by an x2 on the bottom. So that'll be when 4 times 2x to the 4 times 1.5 over x squared. Because I can see you're going to get an x4 over an x squared. So again, we get out our calculator and we work out these components. C4, so this is 15 times 2 to the power of 4. Then we get 1.5 to the power of 2. So this part is going to be 16x4, and this part's going to be 2.25 over x squared. And when we combine all that together, we get 540 x squared. So that means our coefficient for this value of k in this expansion is 540. Okay, question 2. So we have a line, which is 4y equals, and you'll notice I always write out whatever they give me here. You have this line with a constant c, and this is tangent to the curve y squared equals x plus 3 at the point P on the curve. So we can see, like, you could kind of visualize it if you want. We have this curve, and then we have this line which is tangent to the curve at the point P. And it wants us to find the value c. Well, immediately when I see this, we need to get an equation for c. And what I know is when a line is tangent to the curve, then if we equate these two together, then the discriminant will equal 0. And if that doesn't make sense to you, go watch the video. Go watch my exam hack series on discriminants. So we can take this over here, and we can substitute this y into here. So we get a 4 times the square root of x plus 3 equals x plus c. And then we can square both sides. And we get, to get rid of the square root, we get x plus 3 squared equals, and we can expand this out, we get x squared plus 2xc plus c squared. And then we get, oh, that's not squared. Then we get, so on this side we get 16x plus 3 times 16 is 48 equals x squared plus 2x plus c squared, 2xc. Making all kinds of mistakes here. When I expand that out, and then we can take these all over, and we get x squared plus, we take this over, we get a 2c minus 16x plus a c squared minus 48 equals 0. The reason I put it in brackets is because I want you to see where these b's, a's, and c's are. Well, the discriminant of this, because we know this line is tangent to this curve, is equal to 0. So let's put our b squared, which is this value here, 2c minus 16 squared, minus our 4 times our 1, times our c, which is c squared minus 48. So let's expand this out, simplify this, and we'll get a value for c. So this will be 4c squared minus 32. Minus 32 would be minus 64c, and then 16 squared is plus 256. And then we got minus 4c squared, and then 4 times 48. And then a plus 192. So we simplify this down, we get, we have 4c squared, and the 4c squared will cancel, so these two things will cancel. And then we'll get a final equation of 64c equals 256 plus 192 is 448. So we get a c of 7. So that means that when c is 7, this line here is tangent to this curve. Because if we change c, we're going to shift this line, and maybe at other points it intersects the curve at 2 points, and other curves it doesn't intersect the curve at all. And that all depends on your value of c. Okay. Now it says find the coordinates of P. Well, again, we have this curve here of x plus 7. And we also have y equals the square root of x plus 3. So the coordinates of C are when this line and this curve intersect. So let's just substitute this into here, and we get 4 times the square root of, I mean, you could be clever and just put your C value into here, but we'll take it from the top. X plus 7 equals, so we're substituting this into here, so this is not that, what am I doing? Plus 3, and then x plus 7. Again, we can square both sides. So we get 16x plus 48 equals x squared plus 14x plus 49. And then if we take this stuff over, we get x squared minus 2x, take that over, plus 1. And as expected, we get a repeated root because it only intercepts at one point, point P. So therefore our x of P is 1. And then if we want to find our y, we just substitute into here. So we'd get 4y equals 8, which means our y would equal 2. So our point P is at 1, 2. Cool. Let's keep going. Ooh. Just getting some water. So in this question, we got a sector. We got a sector. And that sector has got a radius r and an area a. So why don't we just quickly visualize that? So let's have a look. So it's got a radius of r and this area of a, and it says express the perimeter of the sector in terms of r and a. Okay, well, let's first of all write an expression for the perimeter. Well, the perimeter is going to be r plus, I mean, this is going to be r, and this is, you know, our arc length, we could call s. So it's going to be 2r plus s, you know, this plus this plus this is your perimeter. So we need to find an expression for the perimeter in terms of r and a. So we need this s to be in terms of r and a. And well, let's have a look at our formula sheet. We know the arc length is r theta and the area of a sector is half r squared theta. So we know that a, or first say s, equals r theta, and we know that a equals half r squared theta. So we have s, so let's now write our perimeter, equals 2r plus r theta. Well, that's closer, but it's still not completely in terms of r and a. So we need this in terms of this theta in terms of r and a. Well, we can use this equation here. So a, so from, let's call this 1 and 2. So from 2, we can take a 2 over, and we can say r squared theta equals 2a. So I've just times over by 2. And then I've got theta equals 2a over r squared. So now this equation can become, if we substitute this into here, p equals 2r plus r times 2a over r squared. So we get p equals 2r plus, and then r and r will cancel, will be 2a over r. And that is your perimeter in terms of r and a. Done. Question 4. The diagram shows the trapezium ABCD. Coordinates A, B, and C are shown on the diagram. The lines BC and AD. So these two lines are parallel, meaning that their gradients are the same. And AB and BC are perpendicular to each other, which means their gradients are the negative reciprocal of each other. So that's immediately what I'm thinking. And CD is parallel to the x-axis. So find by calculation the value of h. Well, because CD is parallel to the x-axis, that means that the line, so CD, let's go, the line CD is going to be y equals 3h, right? You know, if you have the line here, and then this is a straight line parallel to the x-axis, y and x, and this is, you know, let's say this point here is, I don't know, 1, 2. Well, that means that it's going to be 2. The y value is going to be 2 all along here. Well, obviously that wouldn't be 1, 2, it would be 0, 2. The y value, so this line is y equals 2. So the same goes for here. So we have an equation for CD. The line equals 3h. And the reason I want that is because I can tell that, well, if we want to find h, we want to find the point C. And the point C occurs when BC and CD intersect. So now we need to find an equation for BC. And how do we do that? Well, we have a point on BC, and remember, whenever we want to find an equation of any line, we need a point on that line and we need the gradient of that line. So if we want to find the equation of BC, we need to find the gradient of BC. And how do we do that? Well, we can find the gradient of AB because we have 2 points here. And then we know the gradient of BC will be the negative reciprocal of the gradient of AB. So let's find the gradient of AB first, which is going to be y2 minus y1 over x2 minus x1, which is equal to y2 is 2 minus y1, which is 0, and then x2 is 0, and x1 is 4. So we get 2 over negative 4, which is negative a half. So therefore, the gradient of BC is equal to 2, the negative reciprocal. So then we can find the equation of BC. From this, we get y minus y1 equals mx minus x1, which you would have seen. So we get y minus the point, so we've got the gradient here, and we've got a point B on the line. So therefore we can find the equation of this line. So y minus y1, which is 2, equals m, which is 2, times x minus 0. So we get y equals 2x plus 2. So that's our BC equation, and that's our CD equation. So to find h, let's just see where these intercept. Or we can just substitute the point in. So the point is at h, 3h, and remember that point is on the line BC. That's way easier. So the line BC, and the reason for that is because I realized that, if I substitute 3h in here, I'm still going to have this x, but we actually have another point, so we have a point on that line. So remember that C is at h, 3h. So if we substitute this into here, we get 3h equals 2h plus 2. That's h equals 2. So your answer is h equals 2 there. That's why I kind of like to do these exams off the cuff, and not to prep too much for them, because I want you to see, like, you know, I can make mistakes as well, but the thing is I realize those mistakes and you know, correct them. Okay, that's that one. It says, hence find the coordinates of D. Well, D will occur when CD and AD intersect. So if we want to find the coordinates of D, we need to find the equation of AD and the equation of CD. Well, the equation of CD is already known because we have it y equals 3h, but our h is 2, so it's y equals 6. So that's the equation of CD. And so the equation of AD, well, we know that the gradient of this line BC was equal to 2. So there, because this is parallel, then the equation of AD equals 2 also. So let's find AD. Now we have a point which is at A, 4, 0, and we have the gradient of AD, which is equal to 2, because it's parallel to BC. So now we have a point and the gradient, so then we can use this equation again to find the equation of AD. So we get y minus, our y1 is 0, equals 2 times x minus 4. So we get y equals 2x minus 8. So D is going to occur when these two intercept. You know, when this line CD intercepts with this line AD, we get the point D. So let's just equate these two. So we get 6 equals 2x minus 8. I'll just substitute that into there. Take this over, we get 2x equals 14. So our x equals 7. So our point, our x coordinate of D is 7. And then to find y, well, we can just substitute this back into this equation here. So we get a y equals, when x equals 7, our y equals 2 times 7 minus 8, which equals 14 minus 8, which equals 6. So the point D occurs at 7, 6. Done. Question 5. So we have a function, and it wants us to express it in this form, which is completing the square. So let's write out our function. Minus 2x squared plus 12x minus 3. Well, the first thing I'd do is I'd factor out the negative 2. And this gives us x squared minus 6x plus 3 over 2. Right, because when I times that in, I'm going to get a negative 3. So I can say plus 3 over 2, or plus 1.5. Now I can complete the square of this. So I get minus 2 equals x minus 3 squared. And then we're going to get a plus 9 on the end. So to get that to plus 1.5, we're going to need to minus a 7.5. Correct? So this and this is equivalent. And then if we times back in now by our negative 2, we get negative 2 x minus 3 squared. That times negative 2 is plus 15. So that's it in that form, which means our A is equal to negative 3 and our B is equal to 15. Let's continue. State the greatest value of f of x. Well, the greatest value of f of x, because this is a negative here, means the parabola will be like this. So the greatest value is when f of x is at the maximum, which is going to occur when x equals 3. Because any other value than that, let's say you put in negative 1, is going to give you a positive, is going to give you a negative value here, and it's going to take off from this 15. So your maximum f of x is when x equals 3. So when x equals 3, this thing equals 0, and your f of x equals 15. So your answer is when f of x is 15. That's the greatest value. Cool. Okay, now we're required to solve an equation here. So remember, we have our f of x equals minus 2x minus 3 squared plus 15. And now we have a g of x. So he wants us to solve this equation. Well, we know that g, so let's say, that is, so g of f of x equals this. Let's figure this out first. So that means we want to substitute f of x into here, into our g of x. Right? We're putting this into here. So therefore, g f of x equals 2 times all of this, which will be, maybe we can just do it, will be minus 4x minus 3 squared plus 30, and then plus 5, which gives us minus 4x minus 3 squared plus 35. So that's our g of f of x. So then let's solve this equation. So then this, this will become minus 4x minus 3 squared plus 35 plus 1, which is 36, equals 0. And that gives us 4x minus 3. So I'm just taking this over. I'm taking this over and then, making it so that x stays on the left hand side. Some of you guys get confused by that. So I've taken that over, and then because they're equal, I can, x equals y and y equals x, same thing. Let's divide by 4, so we get x minus 3 squared equals 9. Square root both sides, we get x minus 3 equals plus or minus 3. So we get two solutions. So when x equals minus 3, we get 0. Or when x equals plus 3, we get 6. So those are the possible values for x. Let's keep going. So this is a trig identity. This is the first video in my exam hack series for this pure 1. And it wants us to show that this stuff is equivalent to this stuff. Remember, this sign, this means this is like equivalent because they're relating to functions, sine of x and tan of x and cos of x. They'll equal each other at a specific value of x. Okay, so let's start with the more complicated side. And when you're doing these ones, I would recommend just instantly writing, your two identities. And you've got your sine squared x plus cos squared x equals 1. Okay, well, instantly I'm saying, well, we have sines, just sines on this side, so we need to try and figure out a way to change everything to sines. Well, I can see immediately that changing this to sine over cos will be very helpful because we can then merge these fractions. So I'm using this, and I get 1 over cos of x minus sine of x over cos of x squared, which becomes 1 minus sine x over cos of x squared. Now if we actually square this, we get, on the top, we get a 1 minus sine x all squared over cos squared x. And we know that cos squared x equals 1 minus sine squared x. So this gives us 1 minus sine x squared over 1 plus, 1 minus sine squared x. Looks like sine 2x. And the key thing here is, because we're pretty close, right? You can see we're pretty close. The key thing here then is to realize that, well, 1 minus sine squared x is the same, and I show you this in the hack series, is the same as 1 plus sine x times 1 minus sine x. Because these sine x is going to then cancel, and you can see that those are equivalent. If you expand it out, you'll see that. So you can say that, well, then this equals 1 minus sine x squared over 1 plus sine x and 1 minus sine x, and then we can cancel these, and voila, we get what we wanted. So there we go. So we've shown that this is equivalent to this. 4 marks. Okay, so II. Then it wants us to show to figure out what x is in this equation. So we get 1. So remember, this is, well, we can just say that this is, we could say u equals 2x, just to show you that this is going to be the same thing, is cos of u minus tan of u squared. Well, this is equivalent to, because u is just a variable, like x is just a variable, is going to equal to 1 minus, because as we showed this above, and remember our u is 2x, so that means that this is just going to be 1 minus sine of 2x over 1 plus sine of 2x equals a third for 0 and pi. So now we can just solve this. We get 3 times 1 minus sine of 2x equals 1 plus sine of 2x. So that gives us 3 minus 3 sine of 2x equals 1 plus sine of 2x. Take that over, we get 4 sine of 2x equals 2. So our sine of 2x equals half. So then, if we want to solve for x, we know what the sine to a half. Well, let's look at our sine graph. Sine graph looks like this. It goes from, this is pi, this is, what we could say was 180, this is 360. It's looking for 0 to pi. So when sine, so half, we're going to get a value, which I think this is 30 degrees, but I'll just double check. Over half is 30. And so that means, because this is 30 here, that means because it's symmetric, this will be 150 or 180 minus 30. Wow. 180 minus 30 is 150. So that means that this, so our inverse of sine half, has solutions for when, you know, x is between 0 and pi, is 30 degrees and 150 degrees. So our x equals 15, we divide through by 2, and 75 degrees. Cool. Let's keep going. So here we have a diagram where the base, so it says that OABC, which is the bottom, and the upper surface DEFG, which is the top, are identical horizontal squares. So that means that the length of their sides, because they're a square, is the same. So OA is the same length of AB. And the parallelogram, so these parallelograms, OE, OAED, both, and this back one, CBFG, lie in the vertical planes. So that means that they have no J depth. They lie in this KI plane. And the point M is the midpoint of AF. Okay. So M is, so that means that AM is half of AF, because M is the midpoint. And the unit vectors I and J are parallel to OA and OC respectively. And the unit vector K is vertically upwards. We have OA, so this OA is 8I. That means that AB is also is the same length, but 8J, and this is 8J because they're the same length because it's a square. And OD is 3I plus 10K. And it says express these each vectors. Well, our AM is going to equal to a half AF. So if we find AF, we can find AM. So our AF is just going to be, let's look up here, it's going to be 8J plus this, which is the same as OD. So it's going to be our AB plus our BF, so that's 8J plus BF, which is the same as plussing OD. So this is plus 3I plus 10K. So our AM is going to equal to half of 3i plus 8j plus 10k. Therefore AM equals 1.5i plus 4j plus 5k. Whoa. And then let's find our GM, Grandmaster. Our GM, well, our GM is just going to be, so GM will equal to our GF plus our FM. And our FM, you know, because this is the midpoint, that means AM is the same as MF. So that means our FM is just going to be minus our AM. So, you know, it's like this vector here is like minus AM. So this would be GF minus AM. Oh, not AM. Yeah, AM, sorry. So this is AF, and AF is, let's just write it. AF is AF minus our AM, which equals AF is 8i minus our AM is, where's AM? Oh, it's just here. 5i plus 4j plus 5k. So therefore our GM equals, this is 6.5i minus 4j minus 5k. Cool, so that's those expressed in terms of I, j, and k. And then it wants you to use the scalar product, which, if you remember, is cos theta equals x dot y over the magnitude of x times the magnitude of y, where you know x and y are these like vectors pointing away from your theta. So GMA, so that means that cos theta of GMA equals, this means, let's have a look here, this means this GMA, so we want them pointing away, so this is MA and MG, so this equals MA dotted with MG over the magnitude of MA and the magnitude of MG. So our MA is going to be equal to minus AM, which in this case is minus 1.5. Minus 4, minus 5. And our MG is going to equal to minus 6.5 plus 4 plus 5. I guess it doesn't actually matter because you can just take the negative out and they cancel. But I just like doing it this way. Let's find the dot product first. So MA dotted with MG equals minus 1.5. So that equals minus 1.5 times minus 6.5, 9.75, minus 16 minus 25, which equals 16 minus 25, negative 31.25. So we have that, so our MA dotted with MG equals negative 31.25. And we also need the magnitude of each of these, so our MA magnitude will equal to the square root of negative 1.5 squared plus negative 4 squared plus negative 5 squared, which equals the square root of 43.25. And the same can be done for mg. That's the square root of 83.25. Now we put all of that in, so we get cos theta GMA. We get theta GMA equals the inverse of cos of minus 31.25 over the multiplication of these two times 83.25, and if you put that in to your calculator, you will get square root of that times the square root of 43.25 negative 31.25 shift cos equals 121.4 degrees. 121.4 degrees. So yeah, the key with that is just to, you know what you got to find, and just find each individual thing out. Cool, that was that one done. Let's keep this ship going. Question 8. The third and fourth term of a geometric progression are as follows. So we have u3 equals 48 and u4 equals 32. Find the sum to infinity of the progression. So we want to find this, and then we go over to our formula sheet and we look for a geometric. For a geometric progression, the sum to infinity is this. So this is our u1 over our 1 minus r. So in order to find our sum to infinity, we need to find our u1 and r. Well, remember that, r is just the common ratio between terms. So u3 times r equals u4. So that means our r equals u4 divided by u3, which equals 32 over 48, which equals 32 divided by 48 equals 2 over 3. So we have our r, and now we need our u1. Our u1 can be found by, we have this other equation, un equals arn minus 1. Remember our a, so un equals u1 rn minus 1. So if we want our u1, we have r, and we can put another one in. So we can say u3 equals u1 of 2 over 3. 3 minus 1 is 2. Remember our u3 here is 48. So then we can find our u1. So therefore our u1 equals 48 over 2 over 3 squared. So we do that, which gives us 108. So now we have both of those things, we can find our sum to infinity. So finally, our sum to infinity equals our u1, which is 108, over 1 minus 2 over 3, which is 1 over 3. So we divide this by 1 over 3, and we get 324. So your sum to infinity is equal to 324. Boom. B. We have two schemes here that are proposed for increasing the amount of household waste that is recycled each week. Scheme A increases the amount of waste by 0.16, so it's plussing 0.16 tons to the amount of recycled waste every week. So you can already see this is going to be arithmetic. So this is plus 0.16. And this is increasing the waste by 6% in the previous month. Recycled each week. Oh, so this is month. Recycled each week and this is month. Whatever. So this is increasing by 6%. So that means that this will be timesing by 1.06 every time, if we're increasing by 6%. So the proposal is that to operate the scheme for a period of 24 months, the amount of recycled, so this is our first term, so this is our U1, and then for each scheme find the total amount of waste that would be recycled over the 24-month period. Okay, well for scheme A, which is arithmetic, we have, we know that UN equals U1 plus, what is it? U1 plus N minus 1D. And we want to find the total amount. So I probably will need that, but we want to find the total amount. So the total amount is the sum of N, 24. So the total amount is like summing up all of the, so how much was recycled in the first month? 2.5. How much was recycled in the second month? Summing all those up for 24 months. So that is SN. For arithmetic is half N times 2A plus N minus 1D. I like to call this U1 plus N minus 1D. So we want S where N is 24. So S24 equals a half of 24 times U1, which is 2.5, times 2 times 2.5. N minus 1 is plus 23. And D, the difference, is 0.16. So let's work that out. So it'd be 12.5 plus 23 times 0.16 is 3.68 plus 3.68. So therefore, the total amount of waste that will be recycled over 24 months will be 104.16 or 104.2 tons. And now for scheme 2, well, it's increasing by, this is your D and this is your R here. So your SN, this is a geometric progression. Your SN is this, which is A1 minus RN, which is U1 1 minus R to the, wait, was it R to the power of N? Yeah. Over 1 minus R. Just make sure that's correct. Okay, so we want this for 24 months as well. So we get S equals 24, and we have our U1 again is 2.5, and we get 1 minus our R, which is 1.06 to the 24 over 1 minus 1.06, and that will be on the bottom, that will be just minus 0.06. So if we put all of this in our calculator, 06 to the power of 24 this is 127.0. So S24 equals 127 tons. So that means that actually scheme B is a more efficient method for recycling. More is recycled through scheme B than scheme A. Okay, let's keep going. Question number 9. The function f is defined by f of x equals 2 minus 3 cos of x for 0 to 2 pi. State the range of f. Okay, I'm just gonna sketch this to figure this stuff out. Oh, it tells you to sketch it below. I'll just sketch it. Let's sketch it to see what our range is. Well, we have f of x equals 3 minus 3 cos of x plus 2. Well, let's tackle each thing individually. Well, we know that just cos of x looks like this. Wow. Well, this is 2 pi, and this is pi. So if we plus 2 to it, which means we shift the f of x up 2, this is 1, we're shifting it up. So when we're plussing the 2 to it, we shift it up to a 3. It's between 3 and 1, so we have something that looks like this, right? Because it goes down to -1. We shift this up, this goes to 1 by 2, and we shift it up, it goes to 3. And then if we times by -3, well, the negative is going to flip it upside down, so we're going to get it like this now. And then times by 3 means the amplitude is going to be tripled. So instead of going up 1, going up to 1 and down to -1, or here going from 1 to 3, it's going to go down 3. So that means it will go down to -3 and up to 5. No, it will go down to -1 and up to 5, right? This will be 2. Hope that's clear. So that means our range goes from -1 to 5. So I just did that step by step. So let's just sketch it again. So it's flipped, it's shifted up 2, and then the amplitude is times by 3. So that makes it go from -1 to 5. This is 2 pi, and this will be 2 in the middle. The function g of x, yep. So state the largest value for p for which g has an inverse. Well, g has an inverse. Remember, g of x is just the same as f of x. But g has an inverse. If we look at this graph, -1, 5. G has an inverse when it's 1 to 1. If it doesn't, then it doesn't have a direct inverse, you know, because we'll get 2 values for one input. So that stops happening at pi, because when we put one value, so let's say we put g, you know, we put g of, I don't know, when we put one value of x in, we get 2 values for g of x. Like if we put here, we can see that past this point we're getting one value, and then past this point for one value, for one input, we're getting 2 values here. I hope that's clear. So your p is actually going to equal to pi. And then for this value, find an expression for this. Well, g of x equals 2 minus 3 cos of x. So now we have to switch from x to g of x to get the inverse. So we get g of x minus 2 equals minus 3 cos of x. That means we get cos of x. We can divide through by negative, will give us 2 minus g of x equals 3 cos of x. Divide by 3. So therefore we get x equals cos of 2 minus g of x over 3. So therefore our inverse of g of x is equal to this. Boom. Okay, we're on the home straight. Question number 10. We have a second derivative curve which has a stationary point at 3 6. Find the equation of the curve. Well, to find the equation of the curve, we're going to have to integrate this twice. So remember that this is the same as saying d by dx of dy by dx. So we can say that we have, let's take this step by step so we can really see what's going on. So we have d squared y by dx squared equals 2x minus 5, and therefore that means that we have d by dx of dy by dx equals 2x minus 5. So now we're going to integrate both sides. You know, we can take this over if we want, so we get d times dx, and then we integrate both sides to give us a dy by dx equals, we go 2x, go up by a power, down the power, it's going to give us x squared minus 5x plus some constant. And then we're going to need to find this constant, but we know that this has a stationary point when x equals 3, so therefore we know that this, when x equals 3, equals 0, which means that x squared, which means that when we substitute in 3 here, we get 3 squared minus 5, 3 plus c equals 0. So now we can find what c is. So we get 9, 9 minus 15, so minus 6, so c equals 6. So therefore we get dy by dx equals x squared minus 5x plus 6. Again, we can, this is the same as saying of y equals x squared minus 5x plus 6. We can take this dx over and integrate both sides. Then we get y. We get y equals x3 over 3 minus 5x squared over 2 plus 6x plus another constant d. And we know that this curve for the second differential passes through the point 36. So now we can find d by just substituting the point 36. So we get c6 equals 3 cubed over 3, which is just 3 squared, minus 3 squared over 2 plus 3 plus d. So then we can find our d. So 3 squared times 5 divided by 2 times -1 plus 18 plus 9. And then we take that over and we get a 9 times -1 4.5, 6 minus 4.5, so we get d equals 1.5. So then our final equation is y equals x3 over 3 minus 5x squared over 2, which is just 2.5x squared plus 6x plus 1.5. And then it wants us to find the x-coordinate of the other stationary point. Well, we have an equation for our second derivative, which is here. And we know that one of the stationary points occurs at x equals 3. So, you know, we have this that equals x squared minus 5x plus 6. And we can factorize that to be x minus 3 and x minus 2. So that's our first stationary point, which is given in the question. So the second stationary point occurs at x equals 2. And finally, determine the nature of each of these stationary points. Well, that can then be found through this first equation, which is the second differential equals 2x minus 5. 2x minus 5. So if we want to determine the nature of each of these stationary points, we just plug this in. So at x equals 3, our second differential equals 2 times 3 is 6 minus 1 equals 1, which is greater than 0. Therefore, this is a minimum stationary point. And then when x equals 2, the second differential equals 4 minus 5, which is minus 1, which is less than 0, so that is a maximum. So the stationary point at x equals 3 is a minimum, and the stationary point at x equals 2 is a maximum. Sweet. And then finally we have question 11, which will most likely be an integration question, as they usually like to ask this at the end of the exam. And it asks us, the diagram shows a curve as follows, and the point 2, 1 lying on the curve. The normal to the curve P intersects the x-axis at Q. Show that the x-coordinate of Q is 16 over 9. Well, in order to do that, I'm thinking, well, I need to find the equation of PQ. And if I find the equation of PQ, I can find where it intersects the x-axis, because it will intersect the x-axis when y equals 0. So let's try and find the equation of PQ. And to find the equation of a line, we need the gradient of that line and also a point on that line. A point on that line is already given to us, and the gradient can be found through the differentiation of this curve. So let's write down our curve equation, which is, if we bring this up and put it in exponential form, we get this to the minus a half. So we can then differentiate that, because we're trying to find the gradient of this line PQ, and we can find the gradient of the curve at P through this differentiation. So we get 3 times down by negative a half of 1 plus 4x. Then we go down by a power, and then times by this differentiated. So we get 4 divided by negative 2 times 3. So this gives us minus 6 over 1 plus 4x to the 3 over 2. So if we want the gradient of the curve at P, that's the gradient of the curve at when x equals 2. So that's going to equal 2. If we plug that in, there, 2 will give us 9 to the 3 over 2. And that is 9 to the power of 3 over 2. And negative 6 divided by answer. So it gives us negative 2 over 9. And you know that makes sense because we're giving a negative gradient, but you can see that the tangent there will be like a negative line. So then the gradient of this PQ line will simply be the negative reciprocal of this tangent line at P. So we can say that m of PQ is then 9 over 2, which is 4.5. So now we have the gradient of PQ and a point on the line, so we can find the equation of PQ. So PQ will be y minus y1, which is 1, equals 4.5, which is our gradient, which we found, minus x minus 2. So this becomes y minus 1 equals 4.5x minus 9. So we get y equals 4.5x. Take that over, we get minus 8. So now we have that equation of PQ. Finally, after all of that, we can get our Q point, which is when y equals 0. So when y equals 0, we get 4.5 x equals 8. So we get x equals 8 over 4.5, which you can see will be the same as 16 over 9, which is exactly what they wanted. Cool, and now the last question in the exam is find, showing all necessary working, the area of the shaded region. Well, this question is not just simply differentiation, because we have this slanted line here which may cause some difficulty. That's why it's 6 marks. So we can say, is the way that I'd approach this, is we can look at this as a right angle triangle here. So if I just magnify that and make it bigger here, where this point Q, which we found, is at 16 over 9. And this point here where the line hits the x-axis will be the same as the point P, which is at x equals 2. So what that means is that the length of this bottom line is 2 minus 16 over 9, which is 2 over 9. And you'll see why I'm doing this in a minute. So the length of this bottom is 2 over 9, and the length of this, so that's the base, and the height will be the y, which is 1. So the length of that will be 1. So that means that the area of this triangle here is equal to half base times height, which is half 1 times 2 over 9, which equals to 1 over 9. And the reason I found that is because I know that if I find from where this is x equals 1 and x equals 0, if I find the area under this curve from x equals 0 to x equals 1, I'm going to also include this extra triangle. So if I find from the area under the curve from x equals 1 to x equals 0, I can then minus the area of this little triangle to get the area of the shaded region. So we can say that the area of the shaded region equals the area, or the integral between 1 and 0 of this line, of this curve, sorry, which is 3, 1 plus 4x, the negative half, dx, minus the area of the triangle. So that's an expression for the area of the shaded region. And now we simply just work this out. So this becomes, we can take the 3 out, we get 1 plus 4x, go up by a power, divide by the power, and divide by the differential. This is 4, so this bottom part becomes 2 between 1 and 0, minus the area of the triangle, or the area in the triangle we calculated before is 1 over 9. 1 over 9. So we get 3 times, well, 1 here will give us the square root of, actually it's between x equals 0 and x equals 2. I made a mistake above, and I mistaked y for x. It's between x equals 0 and x equals 2. And the reason that I realized that is because I realized when I plugged 1 in here, I would get the square root of 5, which doesn't seem very simple. So you need, usually when you have square roots, they will simplify it easily. So having like the square root of 9, the square root of 49, you know, these sort of things, 81. So this is going to give us the square root of 9, which is, you know, 3 over 2, minus, when you plug in 0, you get the square root of 1, which is 1, which is 1 over 2. which equals to 3/2 minus 1/2 is 1 times 3 minus 1/9. Gives us 26/9. And that's the end. Hope you found that useful, and I'll see you later.